Can everybody see my screen now?
Yeah, I can.
Okay.
Yes, I can.
Okay, great. Okay. All right. So so as I said, we're going to be looking at some scientists. I'm going to start off with a few, well, 3 we're going to start off with, and we're going to talk about their lives, and eventually you will share in the latter part of the class, you will share on the scientists that I've asked you to look at. All right, so let's go to some recap. Sorry about that. Not sure what that is. All right, so those are our objectives, which I've already stated. Look at some examples from the history of science that portray science as a way of thinking, investigating body of knowledge, and how those give rise to advances in science, and then to explore the lives of some scientists who have contributed to the development of central aspects of science. So that's the part that you have researched. All right, so those are our 2 main objectives for today. All right, so just refreshing us our memories, because we're going to be looking at the stories I'm going to share with you. I want you to consider how they can be considered to represent or to illustrate science as a way of thinking, a way of investigating our body of knowledge. So as we talk through the presentation, I want you to think about, okay, so what aspect of the need or aspects of the domains of science do these scientists represent? All right. So just to remind us then what we mean when we talk about science as a body of knowledge, we're looking at the fact that scientific knowledge consists of facts, laws, theories, principles, etc., and that knowledge is captured and encapsulated in various forms, such as journals, textbooks, in libraries, in archives, etc. When we talk about science as a way of investigating, then we're talking about how we can use our senses, or how we can use extensions of our senses, that is our instruments, to help us to better understand science. So as a way of investigating, we look at the posing of questions and developing hypotheses, manipulating variables and controlling variables, the whole experimentation process, right? And several other process skills are involved in in thinking about science as a way of investigating. And then when we think of science as a way of thinking, we're looking at thinking through a particular lens. So we have said that, for example, the scientific thinker does not make hasty conclusions, right? And that the conclusions that we do arrive at, those are based on empirical evidence. We embed our judgment in data, in evidence. We attempt to minimize bias, and thinking is a creative process. So the scientist is creative, and we don't take things for granted. So various things that we have talked about when we look at the body of knowledge, the way of thinking, the way of investigating. So as we go through, keep this in the back of your minds, right? And ask yourself, is this portraying science in any of these ways? Or in what ways is this portraying science? All right, so I have 3 scientists, and they all did work in similar area. All right, so we're going to look at Torricelli, Pascal, and Boyle. We're not so much looking at their stories today. We just want to focus on their work, and then you tell me what you think. All right. So as I said, they all did work in a similar area, and that is one of the things I wanted to look at the trend as we progress and see if you can make an observation. All right, so you see the timeline there, Torricelli, 16th, 17th century guy, who was the apprentice of Galileo, and he came up with several hypotheses, right? He talked about the Earth being surrounded by air, right? And you have to consider that at the time when Torricelli was doing this sort of work, there were a lot of ideas, but many of them were not based in any sort of evidence, right? And so Torricelli came up with these hypotheses, and we're going to see what he did. So that's one, and then he came up, he said that air exerts pressure, which was like a new idea at the time. And all objects that are submerged in the sea of air will experience this pressure in the same way that water experiences pressure. All right. So these are some of Torricelli's hypotheses that he came up with at the time. And so, in order to test his hypothesis, he carried out he invented an instrument, right? And you might have heard of the Torricelli barometer, right? So he came up with the first mercury barometer, right? And he noticed in the picture there, he has it in the liquid, and he is showing the pressure, right? Well, that is what he's attempting to show, at least. The pressure that is exerted, so that the mercury in the barometer only goes to a certain level. All right. So this is what Torricelli was able to demonstrate using this barometer that he made, right? He was able to show that the height at which the mercury stood in a column depended upon its weight compared with the weight of air. And he was able actually to produce a vacuum. And this is huge because at the point in time, Aristotle, who we know, Aristotle was pretty much considered a god, right? Whatever dropped from his mouth, people thought that it was, the best thing since sliced bread, if you're familiar with that term. But they basically thought that, he knew all things, almost. So Aristotle had said that it would be possible to produce a vacuum, and Torricelli was actually able to demonstrate that that was not in fact true, right? So, based on what we have said then, which aspect of science or aspects, which domains would you say is or are evident in Torricelli's work, whether you think you see the dominance of science as a way of thinking, way of investigating, body of knowledge? Let me hear from you what you would say.
I would say we're investigating. Oh, we have investigating, sorry.
Sorry, Ava, we didn't hear you very clearly.
I would say so we have investigating.
Okay, only?
Oh, well, you said most, and body of knowledge.
Body of knowledge, all right.
I think it encompasses all three domains. You're not separate, but the main aspect was investigating, but
okay.
All three domains are present in that. Sorry.
All right. What would you, based on what has been presented, what would you use to back up your claim that there is the body of knowledge that is present in the work? How would you substantiate that point?
That's a good question. Anyhow, because I think he would have based his experiment on previous knowledge. He would have looked at what Aristotle said and tried to prove. So based on what was said by his predecessors, he would have said, okay, I don't think that's right. I'd want to validate or falsify it or whatever. And then he will use that knowledge and try to demonstrate that it can be done.
All right, okay. Yeah, it's a little bit weak based on the evidence, but yeah, we could make some assumptions and we could, you know, probably get it in there. All right, so then the strongest point, the strongest aspect, the most dominant, you think, is definitely the investigating.
Yes.
All right, and everybody agrees with that.
Ashley from Bermuda.
Yes, Ashley.
Maybe some of the body of knowledge could have been the information that he used in his experiment, even just simple data like the weight of mercury or information like that. Wouldn't that be a body of knowledge as well?
All right, sorry, just the what theory? What did you say?
I was just saying perhaps some of the body of knowledge could have been the simple information that he was using in his experiment, in Torricelli's experiment, like information that was already discovered and written about, like about mercury and other.
Oh, okay. Okay. Oh, so you're backing up Ava's point. It's a similar point.
Yes.
Okay. I can take that. And if we think about it as well, in terms of the body of knowledge, how Torricelli himself might have contributed to the body of knowledge. In order for us to know what he did, in order for us to be studying his work in this way today, he would have had to have kept an account. So it is clear that he kept very good accounts, because we are now able to read about how he went about doing what he did and what he was able to find. We can even find a picture, a diagram of the sort of thermometer that he used then and the sort of setup that he went about. So in that way, he actually contributed to building that body of knowledge. He added the facts, he added about the vacuum, he added his hypotheses, etc., and his findings. So yeah, it's not as strong certainly as the way of investigating, but yeah, we could make a good argument for the body of knowledge. So yes, I agree with you. What about a way of thinking though? Do we see any of that? Do you see any of that present in Torricelli's work?
I think so, because he had certain hypotheses or whatever, but he also tested it. I mean, like, he didn't just jump to conclusions that those things were correct or that the things that other people were believing and saying were correct. He felt the need to look at it more critically and to test it, I guess.
Yeah, I do agree that the way of thinking is also strong. The formulating of hypotheses, right, is part of the creative process, right? And also, of course, a spirit of curiosity is clearly evident, because I mean, for him to have come up with these hypotheses, first thing, he must have been curious about exactly what it is that is going on and have spent some time thinking about it. And we can see that he was skeptical of Aristotle's, what should we call it now? Aristotle's idea that producing a vacuum would be impossible, because clearly he went about trying to see how he could produce a vacuum, which suggests to us that although he might have said, well, that's what Aristotle said, but you know, I want to see if this is actually true, if there is any truth to this, because one of the things that you realize when you begin to read science history, especially the early history, most of the persons who you read about in the early times were Greek philosophers. And one of the things about the philosophers was that they thought that any sort of manual labor was kind of beneath them, right? So there was this thinking, yes, all right, that you know, philosophers are the people you just sit around and think through things. You don't actually have to have any evidence because you're such a good thinker You know, you just come up with these things and people would accept them. But clearly, Torricelli was somebody who was skeptical and he questioned. I mean, because he was probably asking, so where's your evidence? Where's your evidence? You don't have any evidence, right? And so we see, actually, it's kind of a wave, a change, a move away from just pure philosophy, pure thinking, and you know, coming up with ideas to a sense of, all right, yes, we can think about it, but also we need to back up this thinking with some sort of evidence. So we see that being evident in his work. So, all right. So yeah, so we have managed to see all three aspects of, or all three domains, the way of thinking, the way of investigating, the body of knowledge coming out of Torricelli's work, right? And this is a really, really important piece of work, right? Really important what he did. And considering the time in which he lived, that was like a huge breakthrough, right? So remember that timeline. Let me go back and let's just look at it. Right. So that's 1608 to 1647. So now we're going to move on from Torricelli and we're going to look at Pascal. All right, so Pascal, you may be familiar with Pascal from Pascal triangular math. You might have at least heard of it. And Pascal also hypothesized about, you know, the effect of pressure and gases. So you notice they're within the same sort of vein of work, right? And he came up with a hypothesis that the height of the column was actually due to atmospheric pressure, right? And another one, that the height of the mercury at the top of the mountain should be less than at the bottom, right? Which is basically saying that there would be a change in atmospheric pressure depending on where you are. All right, so let's see what happened next. So Pascal went about repeating Torricelli's experiment, and in repeating the experiment, he used various liquids and containers of different shapes, etc., because he wanted to see if he would get the, you know, similar results under different conditions, which is which theory that we have been said that we need to carry out the experiment under different conditions and in various forms. What does it remind you of?
Inductivism.
Right, yeah. Good. Induction, yeah. Right? Because remember, one of the things that induction says for your, one of the criteria is that you repeat the experiment under various conditions, etc., etc. All right, but that's just a little aside there. So Pascal repeated Torricelli's experiment, and he was able to demonstrate that atmospheric pressure lessens with an increase in altitude. And he did extensive work on vacuums. So while Torricelli was able to show that you can produce a vacuum, Pascal pretty much extended this work. So we can look at Pascal's work as an extension of what Torricelli actually did. All right, so same question. What aspects of science can we see coming out of Pascal's work?
I would say a way of investigating again. I think that's a big part of it, because he did so many different kinds of experiments to verify his hypotheses.
Right. Is there any body of knowledge there? Any way of thinking?
I think all three are there.
Okay. All right. Where would you point to the body of knowledge?
I guess the previous slide we were talking about atmospheric pressure. He and the fact that he was like continuing the work of Torricelli in a sense, basing it on some of the things that he discovered, that Torricelli discovered and thought, I guess.
Okay, but look at this statement as well. Look at the last statement before the question, or the last point before the question.
Right. Yeah. He published his work, so. That'd be a body of knowledge.
Yeah, so that would be a far stronger point, right? In terms of his addition to the body of knowledge, he was able to publish his work, which means that he put it out there, right? For when you put out your work, the scientific community now looks at your work, and basically the scientific community can be very, let's call it brutal for want of a better word, but really, they're going to say, this piece of, once you put your work out there, everybody's critiquing it, right? And it is obvious that his work was able to stand up to the critique, which means that it was good, solid work, which was embedded in good, good practices and stuff like that. So, yeah, so that is the body of knowledge. We clearly see science as a way of investigating. Can you see science as a way of thinking? Anybody? I say argue this. What would you?
I think because of his creativity and thinking of different ways to test
theory,
or his hypothesis rather, I guess. So that to me shows creativity.
Right. Yeah. Yeah, I agree with you. So one, the creativity, the way of thinking might be illustrated through one, the hypotheses, but also in just about how he went about doing his experiment, using these various, he had to spend some time thinking about, okay, I'm repeating this experiment, but how can I modify it so that it is different, and what are the various parameters that I can look at, right? So using the various liquids, using different containers of different shapes, right? Obviously, really embedding his work in the evidence, seeking for that empirical data that he needed, and being curious, being creative. Yeah, I think so. All right.
I have a question.
Yeah, yes.
Do we know how he came up with the hypothesis that air pressure would be less, or atmospheric pressure would be less at the top of the mountain?
I think he might have done some work. He hypothesized at first, but then he actually did an experiment, because it was that he demonstrated that it was actually less. So if I recall the story correctly, if it's the correct person, he actually went, there was this mountain, and he actually went and he carried out the experiment at a high altitude versus low altitude. And you can see what kind of scientist he was. He would have done this a number of times. He wouldn't have taken it like, a single run of the experiment and said that. So he would have done this a number of times, probably different fields, different heights, and he was able to, he came away with this conclusion based on what he saw.
Yeah, okay.
All right. Let me just check in. Is Samuel here yet? Samuel, are you here? No. All right. We proceed. I hope he gets here soon. All right. So that's Pascal building on Torricelli's work, and we proceed. All right. To somebody who is probably a little bit more well known. All right. Boyle, Robert Boyle. And this again, so notice the timeline. So we're getting, going closer and closer to where we are today. So Boyle is considered the father of chemistry. Of course, that is debatable, so we won't even get into that, about who is the father of anything. All right. All right. But one of the things that Boyle did, there was this other guy, because there were several people who were actually involved in this idea of looking at pressure, right? And that is one of the things that some people bemoan, the fact that not everybody gets written into the history of science, so to speak. There are so many persons who contributed, but very few people actually get all the accolades and the acclaim that is associated with it. But we need to understand that the few persons that we read about, there are very many other persons who actually made contributions. And basically, we could look at the ones that we read about as having stood on their shoulders, stood on their work, the work of little people who we never get to talk about. But anyway, you can read about Von Gerrit, but he's not as famous. But he had a vacuum pump. He made a vacuum pump, and he had made that pump to test Torricelli's deduction. So notice that when Torricelli talked about the vacuum, a lot of people got excited and decided, listen, I want to see if this, what this guy got, can I get it as well? So it was a very interesting period that those persons lived in. Sometimes we say today, that really there isn't anything left to be discovered, which is not really true, but it just seems, when you look at the history of science, it seems so much richer and so much more exciting because there are so many unknowns, right? I guess compared to now, we think we know almost everything. All right, but so Boyle showed that air has weight and pressure, right? And he was also able to demonstrate that sound does not travel in a vacuum. One of the things about Boyle is that he had money. His family had money. And that actually is something that affects scientists, because whether you are able to get funding or not is something that very often affects how much work you can do and sometimes the quality of your work. Because in terms of instrumentation, the kind of instrument that you can get. So for example, for us here in Jamaica, we have good scientists, and I guess I could say in some other areas of the Caribbean as well. We have very good scientists, but one of the challenges that we face is that we don't often have the funding to be able to, to carry out our work in a way that would really put us up there on the charts. But even with the limited resources that we have, we still are making, inroads in the international community. But yeah. But as I was saying, so Boyle had money, right? And he placed emphasis on experiment instead of just pure reasoning. He was able to publish, and he didn't just publish a few of his results, he published in great details. And that caused people, even common people, to be able to read about the scientific discoveries, what were the things that were taking place in the scientific community. And at that point in time, we were beginning now to have professional bodies, right, collaborating scientists. So he was able to collaborate with other scientists who were doing work in other areas. And as I said, he was able to use sophisticated equipment and all of that. So he was able to, his experiments were done under more controlled conditions, and that meant that in terms of the integrity and reliability of his results, those would have been like at a very high standard. All right, so this is just a diagram of the pump. Doesn't really mean very much to me, but the point is, I think for the physicists, this would have far more meaning. But the point is, he was able to modify this pump, Von Gerrit's pump, and his pump seemed to have been a far superior one, right? Far superior in terms of its accuracy and the results that it was able to give. So, the same question then, we're looking at the same question. What aspects of, or what domains of science can you see coming out, being portrayed in Boyle's work? All right, Leighton, can I hear from you?
Yeah, I'm there. Investigating. Well, according to, because there's a lot of investigations carried out in order to bring this experiment.
Right. Mm-hmm.
Even I see knowledge as well.
All right. Let me go back to, yeah. Okay. Go ahead. And tell me why you say that. Remember, you have to back up everything you say. You have to back up, right?
Okay.
All right.
Because well, knowledge. Because first of all, it says that he published experimental results,
Mm-hmm.
in great detail.
Mm-hmm.
So that simply means that he had a little knowledge of that experiment.
Okay, so remember now, careful how you say that.
Yeah.
That he had knowledge. Everybody has knowledge. So good, right? But what we want is he added to the body of knowledge, because until you put your work out there so that other persons have access to it, it really is only accessible to you.
Right.
So when it's your personal knowledge, you're not really adding to the body of knowledge, but in making it public, you're then adding to the body of knowledge. You're allowing persons to see new things, right? All right. So he added to the body of knowledge. We wouldn't necessarily want to say that he had knowledge. All right.
Yeah, he added knowledge. Yeah.
All right. All right. So what about do you see any aspects of science as a way of thinking being evident in his work?
Thinking, yes, I see. Thinking as well, where like the last part where it says use sophisticated equipment and control variables. I believe that since it has the variables, then this would encounter for thinking.
All right, Linton, you're going to have to work a little bit more on that. On the argument part, right? Because the argument has to be a little bit stronger. Because if you start with that point about sophisticated equipment, that is going investigative, right? But if you want to focus on the variables, you have to kind of broaden it a little bit more to take in the creativity that would have to come in, right? And the curiosity, the skepticism, etc. Those things that kind of embody science as a way of thinking. But yeah, the three stories that we look at, the three scientists, the Torricelli, the Pascal, the Boyle, essentially we see in their work all three aspects or all three domains of science to different extents. Overarchingly though, I think what is dominant is really the investigative aspect. And that kind of makes sense to us when we think about the age in which they live. We're talking about the basically that period of the Renaissance. Because when we look at science, and particularly when we look at chemistry, the Renaissance came a little bit later for chemistry than it did for some of the other areas, when the arts and everybody they're talking about from the late 15th or 16th century, when those things were budding. The science came on a little bit later, right? But basically during that period, that period where the rebirth of learning and the emphasis was on just acquiring knowledge, and these guys really went out to find out, to experiment and just to find things out. And there was this questioning, and everybody was excited about doing stuff. So we can see, we can understand why there would have been like a huge emphasis on investigation at that point in time, because we had pretty much past the Greek era of just pure thinking and moved into give me some evidence. All right. So those are my three sciences to start off with. All right. One of the points I want to make very strongly for us to understand and begin to think about and appreciate is how each scientist builds on the work of the other scientists, right? And there is this famous quote, I don't remember who said it, but basically what it says is that if I have been able to see farther than those who have gone before me, it is because I am able to stand on the shoulders of giants. And essentially what it means is that whatever progress I make personally, when I progress, my progress is not just my individual progress, but it actually has been enabled by those persons who have gone before me, who have kind of like charted the way to allow me to, you know, discover something or to find out something or to reach those heights. So it's really important that we give some sort of acclaim and recognition to all scientists, even the ones that we don't really know their names, because they have all contributed to the development of what we know today. All right, are you ready for a break, or you can go?
Let's keep pushing through and end early.
All right, okay. All right, no problem with that. No problem at all. All right, so we're going to continue then, and we're going to look at some other people who also made contributions to the development of science. In particular, we're going to start off with this guy, William Beaumont, right? It's in the file I sent you. So we're going to read that story, and we're going to talk about it. It's a very I love it. It's a very interesting story. All right, so I hope you will enjoy it as much as I have. All right, so I'm going to ask you to get your Beaumont out, William Beaumont, and we're going to read that, and then we're going to have a discussion, and then we're going to continue. So everybody has the file just to make sure.
Yes, we're reading the whole document.
Yes.
No, just the William Beaumont note. Right?
Okay.
We're going to look at the others, but for right now, that's the one I wanted to focus on. All right, so I'm going to give you a little time to read it. As you read it, I want you to just make note of the most salient points, right? So have in the back of your mind, science is a way of thinking, science is a body of knowledge, science is a way of investigating, but also pick out of what you read, pick out the lessons. What are some of the lessons that you could take away from these stories that you could possibly share with your students and how it could help them? All right, so let me see, probably 10 minutes. I'll give you 10 minutes to start with, and then I'll see if you need some more time to finish your reading. All right, so you read first, and then you can probably discuss it among yourselves, and then we'll have a couple of people share, and we'll talk about it a little bit, and then we move along. All right, so Do you still need a little more time?
Yeah.